Okay, good morning to all of you. In this class, we are going to discuss about representation or expression of gradient, divergence, curl and Laplacian operator in cylindrical coordinate system. In short, here I have been written CCS, cylindrical coordinate system, by using OCCS, that means orthogonal curvilinear coordinate system. In our previous class, we have been discussed in detail about representation of gradient, divergence, curl, and Laplacian operator in spherical polar coordinate system by using OCCS. In that class, I told that to understand the importance of OCCS for this topic and also this topic, it is very important. So only for that, I suggest that we go through that video where I have been discussed the importance of OCCS. So here in this video link, I will be give about the importance of OCC video, that you have to watch first, then you have to watch this one. Okay, so now we have to start this one. Here I have been drawn in the figure the typical cylindrical coordinate system. This is one cylinder, and here this is the z-axis, x-axis, y-axis, and this is the cylinder, and on this cylinder surface P is the point located. If we are going to consider the Cartesian coordinate system, let this point P position is your x, y, z. Now we have to convert this x, y, z in terms of r, theta, phi, because here you can see this point P is intersection of three curves in this cylindrical coordinate system. Carefully you have to watch. This is one curve, radial component, like this. It will be passed through the point P, and another one is like this type of curve on the surface. This curve can be found by the variation of the theta. Okay, and another curve along this way. This z axis suppose passed through this way, so this one is the another curve which will be parallel to the z axis. So here these three curves are intersects with each other at this point P. That is one is your radial, another is your this one, and another is your this one. So if we are going to consider the unit vectors of these three curves, that means tangent to the unit vector. So tangent for this one is this along this way, and the unit vector along this way. Tangent for this curve, that means along z axis, will be this way, and corresponding unit vector will be this way, and tangent to this curve will be this way, so unit vector will be this way. So here you can see that these three unit vectors are perpendicular with each other, so hence cylindrical coordinate system also called as your orthogonal curvilinear coordinate system. In detail we have been discussed in that video. Okay, that link I have been given in this description. You just watch that first. Clearly you will be clear that how in cylindrical coordinate system these three unit vectors are perpendicular with each other. So no need to draw here these three curves. For your understanding purposes I drawn, so don't draw this one, but you draw this system. Okay, this is your P and this is your x, y, z, right? Now here, as I told that if we are going to consider this R curve is one curve, and this is your another curve, and this is your another curve, then U in case of OCC, the U curve is transformed to radial R, V curve transformed to theta, and W curve transformed to Z. So this theta is nothing but polar changes of polar angle, and Z is the along Z axis. So collectively it is considered as equation number 1. So same thing it has been written, let P, X, Y, Z be any point in OCCS where three unknown curves such as U, V, W. In OCCS we do not know what type of curve U, V, W will be there, but in case of cylindrical coordinate system, U is your R, V is your theta, and W is your Z, right? So corresponding unit vectors will be ER cap, E theta cap, and EZ cap, that we are going to be discuss later here. So from this figure, we have to first find out the x, y, z component, right? Now we are going to go for the triangle ORQ. Here you can consider, see, this is the normal. This is the normal drawn from this point to the z axis. Okay, so this height is nothing but this height. Okay, and this length, this r length is nothing but this one, r itself. So here this will be the y component, this is your x component, and this is your z component of P, right? For this cylindrical coordinate system. Now if we are going to consider ORQ triangle, ORQ, then sine theta will be QR by OQ. Sine theta, here this is theta, this is the 90 degrees. So sine theta will be QR by OR. That means QR is your y. Okay, QR is your y component, and sorry, QR by OQ. QR by OQ sine theta. Okay, because it is your perpendicular 90 degrees. So this is your diagonal. So QR by OQ means y by r. So y will be r sine theta. Let this is your equation number 2. Similarly, consider the triangle OQR. OQR. Now cos theta will be how much? Cos theta will be, here this is the base, OR by OQ. OR by OQ. OR is nothing but x component, x by r. So x will be r cos theta, and here z is nothing but z component, z will be z. Let this is your equation number 3, and let this is your equation number 4. Now as I told that this UVW unknown curves has been transformed its known curve in case of cylindrical coordinate system as r theta z, then corresponding unit vectors are pause the video and write down the note. Okay, in this case unit vectors are for u which is transformed to r, the er cap, for theta e theta cap, z e z cap. Okay, as we know, to find gradient divergence curl, previously we discussed that to find out the gradient divergence curl and Laplacian in CCS, here cylindrical coordinate system, from OCCS, it is essential to evaluate H1, H2, H3 in CCS. Okay, because may you know that in case of orthogonal coordinate system, H1, H2, H3 parameters has to be evaluated. That we have been evaluated in our last class for spherical polar coordinate system. Here we are going to find out in case of cylindrical coordinate system. So first, if we are going to consider in OCCS, the H1 is nothing but del x by del u square, del y by del u square, del z by del u square. So here x, y, z in case of cylindrical coordinate system, we found r cos theta, r sin theta, and z, that we have to substitute over here. So del by del r of yes, here u is nothing but r. Okay, so del by del r of r cos theta square, del by del r of r sin theta square, del by del r of z square. So here derivative with respect to r means it will be 1 only cos square theta. It will be r means 1 only sin square theta will be here. So cos square theta sin square theta will be 1, and here you can see del by del r, z is not the function of r, so it will be 0. So cos square theta plus sin square theta will be 1. So h1 root over will be also 1. So h1 we found 1. Now h2 in case of OCCS we found, you can check your note previously, del x by del v square, del y by del v square, del z by del v square, but here we consider the theta. So del by del theta of x in case of CCS is your r cos theta. In case of CCS, y equal to r sin theta and z equal to z. So del by del theta of r cos theta, del by del theta of r sin theta, del by del theta of z. Del by del theta of z will be 0. Here del by del theta of r cos theta, derivative with respect to theta sin theta will be cos theta. So r cos theta whole square. Here del by del theta of r cos theta, r is constant, cos theta derivative is minus sin theta. So r minus r sin theta whole square. So this value is nothing but r square sin square theta. This value is r square cos square theta. So r square can be taken common. So sin square theta plus cos square theta will be 1. Root over will be answer will be R. So H2 we found R. Similarly H3 we know in OCCS this is your del x by del w square, del y by del w square, del z by del w square. So here W is nothing but, in case of CCS, W is nothing but Z. So del by del z of R cos theta, del by del z of Y is nothing but R sin theta, del by del z of Z. So here this R cos theta not function of Z, R sin theta not function of Z. So these two terms will be 0 and the derivative of del Z by del Z will be 1. This is 1. And square its corresponding root over will be 1. So here we found that H1 is your 1, H2 is your R, and H3 1. Okay, now we are going to go for the gradient in cylindrical coordinate system. To find the gradient in cylindrical coordinate system, first we have to consider gradient in orthogonal curvilinear coordinate system. So we know that in orthogonal curvilinear coordinate system or in your general coordinate system, the gradient of a scalar function is nothing but this one, 1 by h1 del by del u of phi e1 cap, 1 by h2 del by del v of phi e2 cap, 1 by h3 plus 1 by h3 del by del w phi e3 cap. Let this is your equation number 5. So in case of CCS, cylindrical coordinate system, these values we have to put h1, h2, h3 are 1 and u, v, w is your r, theta, z, and corresponding e1 cap, e2 cap, e3 cap are er cap, e theta cap, e z cap. Just substitute over here in equation number 5. The equation number 5 will be how much? Here h1 value is your 1, so and u value is your r, e1 cap is your er cap. So del by del r of phi er cap. So this term here h2 is nothing but r, so 1 by r del by del theta of phi, del by del theta of phi, because v is your theta, your w is your z, so and h3 is your 1, so del phi by del z e z cap. So this is the required expression of gradient of scalar function of phi in CCS. So in CCS means this u is nothing but your r, theta and phi. Okay, just correct it, r, theta, phi. Now we are going to go for the divergence in CCS. So first we have to consider divergence in CCS. To find the divergence in CCS, first consider the divergence in OCCS, orthogonal curvilinear coordinate system. In orthogonal curvilinear coordinate system, divergence of a vector field is nothing but this one. Let this is your equation number 6 that we know, and here we have to substitute the value of h1, h2, h3 whatever we have been found now, and u, v, w, that means r, theta, z values of CCS in equation number 6. We can get del dot a will be equal to, here you can see h1 is 1, h3 is 1, h2 is your r. So this multiplication of 3 will be r, 1 by r. Here u is nothing but r, del by del r of h2 is your r, h3 is 1. So r, h3 is 1, so 1, so a 1 only. So del by del v means del by del theta. So h3 and h1 both are 1, 1. So only a2 will be here. And d del by del w is here in case of CCS is your z. So del by del z of h1, h2. h1 is 1, but h2 is what? R. So a3. Okay. So just multiply 1 by r with each term. So del dot r will be equal to 1 by r del by del r of r a1 plus 1 by r into this term del by del theta of a2, 1 by r into del by del z of a3. So here del by del z is here. So r is the constant taken outside, r and r got cancelled. Here last term is your del by del z of a3. This is the required expression of divergence of a vector in CCS. Means here a is vector in CCS means function of r, theta and z, r, theta and z. So here I mistakenly written phi. This is your r, theta and z. Okay, so correct it in your note. Right, now we are going to go for the curl in CCS. First we have to consider curl in OCCS. Curl in OCCS is this one. Let this is your equation number 7. Now we have to put the value of h1, h2, h3, u, v, w, e1 cap, e2 cap, e3 cap values in this equation number 7. What we are going to get? See, already h1, h2, h3, h1 is 1, h2 is r, h3 is 1. Okay, and e1 cap is your er cap, e theta cap, ez cap, and here H2 is nothing but R, and H3 1, H1 1. Okay, R, sorry, here U V W means R theta Z, R theta Z. H1 is 1, H2 is R, H3 is 1. So A1, here A1 into R, or R into A2, A2 into H2, that means R into A2, R into A2, here A3 into 1, A3. So here 1 by H1, H2, H3, that means 1 by R, because H1 1, H3 1, H2 R. So 1 by R. This is the required expression of curl in your cylindrical coordinate system, or in this form also you can write that 1 by R is here. Now ER cap is nothing but del by del theta of A3 minus del by del Z of this one, written over here, minus 1 by R is here, R E theta cap into this minus this del by del R of A3 minus del by del Z of A1. Okay, next plus EZ cap is here, 1 by R1 is here, and this del by del R of RA2, del by del R of RA2 minus del by del theta of A1, del by del theta of A1. This is also another form of curl of the vector function in cylindrical coordinate system. Okay, so here same, this expression is same, only 1 by R I have been multiplied with each term. See, here 1 by R is going to be multiplied with this one, so 1 by R del by del theta by A3, 1 by R is going to be multiplied with this one, R is constant taken outside, R got cancelled, so A del by del Z of A2, and here R is multiplied with this, R is multiplied with this, so, and here R is there, so here R got cancelled, so this term is nothing but this one. Again R is multiplied with this one, so del by del R of this one, that means this will be derivative has to be there, so simply 1 by R, this term has been written over here. So the curl in CCS, cylindrical coordinate system, of a function A, vector function, in CCS means this is your R theta and Z. Correct it in your note, okay, R theta and Z, because here the A is nothing but in your CCS, because it is transformed. So curl in CCS, either you can write this one or this one or this one. So I suggest to all of you that you remember in this matrix format. It is more than sufficient. Now we are going to go for the Laplacian in cylindrical coordinate system. So to find Laplacian in cylindrical coordinate system, first we have to consider the Laplacian in your OCCS. This is the nothing but Laplacian of a scalar function phi in OCCS, right? Now here we have to consider, this is the equation number 8. Now we have to put the value of H1, H2, H3 and UV, W values in equation number 8 for CCS. For CCS, these values we have to put in equation number 8. Then we are going to get the expression, required expression of Laplacian in cylindrical coordinate system. So here H1, H2, H3, we found this one and this one. H1, H3 is your 1, 1, H2 is R. So this one 1 by H1, H2, H3 will be 1 by R, del by U, del by del R. Here H2, H3, H2 is R, H3 is 1, H1 is 1. So this will be R del by del U, that means del by del R, del by del R of phi. Here del by del V means del by del theta. So here this will be H2 means this one will be 1 by R, del by del theta will be, because V is your theta, and del by del Z. Here this will be R. This see, H2 is R, H1 and H3 is your 1 and 1. So R into del by del Z of phi, because W is your Z in case of CCS. So here 1 by R, del by del R of this one. Just consider the derivative, consider the product formula for this. So this will be R into del square phi by del R square plus del phi by del R, because del by del R of R is 1. Okay, then plus here you consider del by del theta. So 1 by r is constant. Taken outside, it will be del square phi by del theta square. Del square phi by del theta square. Plus, here r is constant. Taken outside, del square phi by del z square. 1 by r is here. Now we are going to multiply 1 by r with each term. What we are going to get? R got cancelled. We found del square phi is your equal to del square phi by del r square plus uh, um, 1 by r del phi by del r plus 1 by here 1 by r 1 by r 1 by r square del square phi by del theta square. Here r got cancelled, del square phi by del square phi by del z square. So this is the required expression of Laplacian in cylindrical coordinate system. So here we have to stop our today's discussion. In next class we are going to discuss velocity and acceleration in cylindrical coordinate system. Okay, so thank you so much for watching this video. Thank you.